Hello there, class. Mr. Wood back again. We're looking at worksheet 2, balancing word equations. Before we start, you doing okay? Having any problems? Let me know. I think I got all the video issues worked out from earlier in the week. Hopefully this is working fine. Let's go ahead and take a look at worksheet 2. Thought I'd do a couple of problems with you. Nothing really new here, just more practice, bringing in balancing and word equations, the stuff we already covered. So I thought I'd do a couple of examples of balancing and then one of the word equation problems for you, just so you get an idea of what's going on. So I thought I'd do number 2 and number 5. Those seem to be good examples. Number 5 is a little strange. We'll talk about that when we get there. Number 2 first. As always, remember you can't change the formulas. You have to leave those alone because presumably Mr. Wood wrote the formulas correctly when he made the problems. Start with an element inventory. We always start the same way. What do we have? We have aluminum. We have sulfate. Remember, sulfate's present on both sides, so I can keep that together. Calcium and hydroxide. Okay. Again, I like to divide it up right under the arrow, so that makes it easier to keep track of what's where. I have 2 aluminums. I have 1 on the product side. I have 3 sulfates, and I have 1 on the product side. Do be careful. I don't have 4 sulfates. I have 1 sulfate. SO4 is sulfate, and there's only, right, 1 of those, yeah? Calcium, 1 and 1, and then hydroxide, 2 and 3, okay? Again, me no order, that's metals first, so I'm going to start with aluminum. I have 2 and 1 on the product side, so we need to multiply the product side by 2. That changes my aluminums to 2, and it changes my hydroxides to 6. I have another metal, calcium, but it's both 1s right now, so I don't need to do anything with that. Sulfate, ions, right? Metals, ions, amino. Sulfates, 3 and 1, so I'm going to multiply this side by a 3. Changing the sulfate to 3, and then also the calcium to 3. Don't worry, it'll all work out. Hydroxide, another ion, 2 and 6, which means I have to multiply the reactant side by 3, right? That changes my calciums and my hydroxides, and everything is balanced, nice and easy. Okay? Hopefully that was pretty easy for you. Let's take a look at number 5. Little more challenging one. Anytime you have multiple substances and different elements, or multiple elements in different compounds, that's what I meant to say, it gets to be a little tricky. Nothing you can't handle. You're smart people. Element inventory, same as before. I have carbon, I have hydrogen, I have chlorine, and I have oxygen. Writing it up, I have 2 carbons, and then 1 carbon on this side. 3 hydrogens, and then careful, 2 and 1 makes 3 hydrogens on that side. Gotta remember to add them up, and there are 2 spots. Chlorine, 1 and 1. Oxygen, 2 and 3. Looks kind of weird. Me no order. Do I have any metals? Nope. Ions? Nope. Non-metals? Yeah, whole bunch of them. Let's start with carbon. 2 and 1. So multiply this side by 2. That changes my carbons to 2 and my oxygens to 4, and 1 more makes that a grand total of 5. Okay? Hydrogens are okay, chlorines are okay, oxygens are what's left, and we have that problem again. 5 divided by 2 is 2.5. So that would be ideal, but I can't have half a molecule. That's not how we roll, so we have to go through and double everything. That means this, which was a 1, becomes a 2. That becomes a 5. That becomes a 4. That goes to a 2, and that goes to a 2. And we can go through and double check. Carbons goes to 4. Hydrogens go to 6. Chlorines go to 2. Oxygens go to 10. Okay, on this side, carbons go to 4, oxygens go to 8 plus 2 more, so that makes 10. Hydrogen goes to 4 and 2 more, so that makes 6. Chlorine goes to 2. What do you know? Everything worked out nicely. Everything's balanced. All right. Hopefully that's not too bad for you. One more I wanted to do, just looking at the word equation side. So this gets a little trickier because now we have to take the words, turn them into formulas, and then balance the formulas. Multiple steps. So 13 is the one I was supposed to do with you. Solid potassium chlorate will break down to form solid potassium chloride and oxygen gas. Okay, not too bad. Let's translate that into formulas first. Okay, potassium chlorate. Well, potassium is K. Chlorate, ClO3. That has a -1 charge. That has a +1 charge. There's no problem there. And that is a solid. Will break down. Okay, so it's not plus. So let's changing up our system a little bit here. Will break down. That's wordage for reacts, yields, forms, right? Arrows. To form, okay, solid potassium chloride, KCl, and oxygen gas. Nope, sorry, forgot my solid. Solid potassium chloride and oxygen gas. And again here, oxygen gas, O, but O's diatomic. Right? It's one of the Hofbrinkels. So it's always O2, and this, of course, is a gas. All right, so that part's good. Remember, I can't change any of the formula. And now we need to balance it. Should be pretty easy. Potassium, chlorine, oxygen, 1, 1, 3, 1, 1, 2. Again, we have that 2 and 3 problem. Can make them both 6. So this side needs to be multiplied by, okay, sorry. Should start at the beginning. Metals are balanced, non-metals are balanced. We're down to oxygen. Got a little ahead of myself. 3 and 2 on the oxygen, so we need to make this side into a 2 to change the potassium to 2, the chlorine to 2, and the oxygen to 6. We multiply this side by 3 to change my oxygens to 6. And now I need to go back and clean up the potassium chloride. They're both 2. Throw a 2 in front there. Everything is balanced. All right. Hope this is working out for you. Hope this all makes sense. And if not, get a hold of me. Let me know. Have a good day.